Oh.
はい。では、次の、セッションを開始します。次は KC ウエストさんで、Building Domain Specific Languages Pro です。はい。
Thank you. Thanks for coming. So yeah, this is domain-specific languages with Perl. Last year, Jesse Vincent gave a talk here that covered the same topic, slightly different aspect. I'm going to dig into some of the specifics of an implementation that I've been working on recently. So we'll get to see sort of what's underneath of the outside language. And that'll basically be some, intermediate level tips and tricks for manipulating Perl to make it look the way you want it to. So as it says, I'm Casey West, and I know that Ingy's got a thing with his name, but I'm still just known as Casey West. I don't have any other fun names. So in any case, DSL it means domain-specific language, and the point of writing one of these things is to program close to the problem domain. This is basically a definition of doing domain-specific languages from the pragmatic programmers. And they wrote a good book, and one of the things that they recommend is that you write the smallest subset of a language that you need to in order to solve a particular problem. You get really close to it, to the problem, in order to solve it. So we can manipulate Perl to do that. So one question is, how close should we get? And basically, my take on it is to design and code in your user's language. In my case, and for the example that I'm using, I was working with some Perl programmers and some people who aren't programmers, but they speak and read English just fine. So I tried to make a hybrid that worked with both. So, how close is too close? Well, I guess you just have to feel it. In particular, whenever you're manipulating Perl, there's a lot of things that you can do and a lot of things that you probably should not do, but it still lets you do anyway. So you have to kind of strike a balance that you feel comfortable with. So I'd like to work from an example. And my example in particular comes from functional web testing, with Selenium in particular. Who is familiar with using Selenium for functional testing? I don't know if you need to. OK, so we have a lot of people who use Selenium. So it drives a web browser, and what you do is you basically mimic being a real user touching your web application with a web browser. And the problem that I had is that the code, it really had to be readable by non-programmers. It had to be documentation that someone could understand if they didn't understand Perl. And the idea there is so that we can share it and use the code to understand website workflows, the way that people are supposed to navigate a website in order to use it. So I'm going to jump right in and show you guys some example code that actually works with this particular DSL. So first, it's all about testing. So I have a test function, and that tests a particular session. And a session is a series of statements about what the website is supposed to do and the way that it's supposed to look whenever you're using it. So you open a web page and you click on a button and you type into a field, and that manipulates the way the application works. And you write sentences, and each of them have to be true. And if one is not true, then you failed. The test failed. So here's an example taken from an application at work. The first thing that you see up at the top, and I can use my fun laser pointer right there, is calling the user management screen. And that's a function that you can see, and I'll explain that in a moment. But essentially what it does is it logs into the web application, and it navigates to the user management screen for you. And then you type a username into the filter by username. You click on View User List, and that's going to refresh the page, in which case you should wait about 30 seconds for it to load. And the title of the page after it loads should be Admin User Management. So that's getting us somewhere. So then we want to click on a link, and the link for the username, the text of a link for the username should also be the username. So that's saying that the link text you see should also be an email address. And so then we'll go ahead and click on that link, and we have to wait about 30 seconds for the page to load. And the title should be Admin User Management again. So at this point in our application, you happen to be at a screen where you can see the details of a user, and you can edit them. They're in input fields. So you want to test the value of the username is, in fact, this email address. The value of the real username is test user. And then if we click submit, then we should get a message saying that we were able to save an existing user. Yeah, that's what this says. Sorry. Yeah. So the text of this element in the web page is data was saved after we reloaded the page. So this is very English-like constructs, and the goal is again to make it so that humans can read it who don't understand programming, but the computer also understands it, and we're using Perl. So the reason that I wanted to use Perl is because we use Perl at work, and also because it has a CPAN. So I can leverage anything that I have on CPAN. I can write other modules. I can interface with this programming, this little DSL I've written on top of Perl to make it more specific for my purposes. And I can tie anything together with it. So that was really important to me. In other words, for most cases, for 90% of the cases, it's going to look very much like this, sort of an English-looking thing, very easy to read. But for the 10% of the time when I need to do something very complicated, I can just start writing Perl code, and it's not going to hurt anything. So I'd like to dig into the specifics a little bit. We have a user management screen here. And what happens is that navigates to the user management screen. I actually have some slides that are going to show that I don't want to show, so I need to shut that off for a moment. Apologies. Okay. So we have the user management screen. So let's take a look at what that looks like. This is a part of the DSL that I think could look a lot better, but it's an implementation that I've gone with so far. I wanted to be able to define macros. They're kind of like subroutines. They have a little bit of extra functionality. And this is the syntax to do that. There's a def function here, and you give it the name of the macro that you'd like to create, user management screen, and then you assign to it a block. And inside that block will be the code that you want to run. Again, most of it can look a lot like the English like we saw before. So the first thing we do is we call login, which is another macro, with two parameters, which we pass in, U for username, P for password. Then we check that the title should be a project list. We click on my account, wait up to 30 seconds. Title should be account after that's finished. We have some really crazy drop-down menus that don't operate in a standard fashion. So I have to literally invoke these JavaScript events. We mouse down and then mouse up, mouse over, and click on a menu, and that creates that brings the drop-down up. Then we navigate down to the particular selection we want in the drop-down. And then once we click on that, then it will load up the user management screen. So we saw the use of login, which is a macro, and it took arguments. And in this particular case, we open up the particular server that we want to go to. Then we type the username into credential 0, type the password into credential 1. You can see this is just a function that we call an arrow, and that gives us the argument. And I'll explain that in a little while. Then also, we check that the title should be login. We click on login now, and the page should load in 30 seconds. So that's the example language that I'm working with, and I'm going to sort of deconstruct it now and talk about some of the things that I did underneath to make it look like this. First trick is the use of function prototypes. For a lot of our code, with the way that I think Perl programmers are writing code today, Prototypes are fairly useless. If you're writing object-oriented code, then prototypes don't offer you a whole lot unless you're using code that is sort of taking advantage of a prototype as a side effect. And even when you're writing functional sort of programs or declarative programs, you're not necessarily using prototypes. But in this case, there are a few tricks that we can get away with that actually help us out. And we can make use of those side effects for our purposes. So we saw the block function, which we use to assign a new macro. That really just returns a subroutine or a piece of code that we can call later. And you see that it takes a curly brace piece of code here, and that's a subroutine. And it's an anonymous subroutine, but you can see that it doesn't use the word sub as any kind of keyword. And the way we get away with that is by using this prototype here, the ampersand, which says the first argument to this function must be a subroutine. And Perl's interpreter, as a sort of side effect of this, has decided that in this particular case, if you want to, you can pass that subroutine without the sub keyword, and it will understand what you mean. You have to use the prototype in order to get away with that. If you've used a lot of exception handling modules in Perl, they have a try and a catch block, and this is how the try and the catch are created. Another quick tip are L-value subroutines. So, or L-value functions, where you can assign values to functions. And another aspect of that will be, well, you'll see in a moment where we use the want module. But in this case, the def function is an L-value function. You can see that it takes an argument here, get username, but also you can assign to it. You can assign, the result of block. So here's a simple one that just makes a really badly randomized username. And here's an implementation of def, where we specify that it's an L value. Now we use this attribute here, which is a built-in attribute called L value. And that says to the Perl interpreter that you can use the function on the left-hand side of an assignment. And we have to do some extra work, though, because what we want to assign is a subroutine, and then we want to save that subroutine and use it later. And Perl, by default, doesn't let you do that. But there's a want module, which when you use it, you can get a few functions. One of them is this want function, and you can ask if we're in an assignment context, and you can get the value. So in this case, what I'm going to do is create a new function that's named the macro. So in this case, it was get username. So in my caller, the package that called me, I'm going to create a new function called get username, a real function that you can call later. And inside of it, I'm going to push onto an argument stack the arguments that I'm getting passed in, and that's at runtime. And then I call session run, and I run the code. This is something that happens under the hood. And then once that's finished, I store the value. I pop the arguments off the stack because I'm done with this macro, and then I return. And then this is some stuff that I need for want.pm. You have to use lNoReturn when you're using an L value, and then you have to finish up with return because I think the compiler complains if you don't do that. So this is an example of using those L values, and we're going to get into it a little bit more. Another trick that I have in here is functions with multiple interfaces. So you can create named blocks, and that's something like the block command. And if you saw in the beginning, the session command does this as well. Session takes a block, and it's sort of a named block. But you can also access it as an object, and you can use it in multiple contexts. So it depends on how you're calling it. In this particular case, session creates a new session, and that's sort of like a scope. You can see, with the curly braces, it creates a literal scope. But within the confines of this DSL, what happens is I create a new Selenium scope. I make a new Selenium object, and I fire up a new, fresh web browser. And in this case, I can invoke other things off of session. I can get this particular session ID. They're all unique. I can get the Selenium object that we're working with. And here's an example of setting the speed where I'm slowing down Selenium in this case. And then I can run more commands and whatever else I want to. This is kind of complicated, but we can talk about it a little bit. Basically, we use the name block, or we get an object, and that's based on the context and the way that you invoke the session function. So let's take a look at that. So here's a simplified version. The first thing that you'll see that we do is we declare a session with a prototype right up front, and then we declare the real session. And the reason that we have to do that is because inside of this function we're using it again, and we're using it with a different kind of interface than it might expect. So what we're saying here with this prototype is that no arguments are required, but we will accept a block of code and a list of things after that. So at the top here, this is from want.pm again. If we want an object, if the way that this is being used is in an object kind of context, then we'll return the current mode, which is a session. And when you get that, then you can invoke methods from there. If that isn't the case, then what we think you want to do is run a code block. And so we'll push a new session onto the stack, and we'll run the code that you've given us, pop it off, pop off the session off of the stack, and then return the value that you've given us, or that we've gotten as a result of running the code. Again, we have another return in here, and that just makes Perl happy. So these are the building blocks for this particular DSL. And with these components, you can get scopes. You can define macros, which are reusable in the code. Those macros can get arguments with a sort of standard interface that doesn't require Perl variables or the knowledge of sigils or anything like that. And then what we need to do next, though, is start writing some of the components that let us build a more natural language out of Perl. So how about writing code in sentences? Perl, I think, helps us write English code. Sometimes it gets in the way, but in this particular case, I think I found a decent way around it. So here's some examples of English code. You can see these look fairly familiar. The title of the page, should be Twitter, for example. The value of a user input field shouldn't be no input. Text matching what are you doing should exist, and the page should load in 2 minutes. So I'd like to explain some things here. So part of writing a DSL is designing it. It isn't just typing out the code, but you kind of have to design something that feels natural. In this particular case, I had to really think about the way I was using it. I'm writing something that does functional testing on the web, and that's a very specific kind of context, so I need to use words that seem to make sense in that particular case, so that whenever you read it, you kind of know what you're doing. You kind of know what you can expect the code to do. One of the things that you see here is a lot of curly braces. I tried to eliminate as much sort of syntax as I could, but due to the constraints of Perl's parser, I had to take anything that could be a string or a number kind of input and wrap it in these curly braces. What I'm doing is actually creating code blocks, and those code blocks will return whatever's inside of them. So what are you doing is a string, and that string is returned from the code block. You'll see later, as an example, that matching is a function that expects that code block and it knows what to do. But what I found out was that I actually got a lot of consistency out of this that I didn't quite expect. So you see here, page should load in 2 minutes, and 2 is wrapped in curly braces, and I need that to happen. But what I found out was that anything that is sort of variable, that isn't part of the language, that is user input or some kind of a location identifier for a web page or inside of a DOM, I can put that in curly braces, and you know to expect that. So when you're typing this out, it actually flows really nicely from your fingers, because you expect that whenever you're going to do anything that could be a variable, you put it in curly braces. And everything else is part of the language, and you just type it out. So I thought that was a kind of a nice benefit. And so what we're going to do from here is we're going to start deconstructing a couple of these. We're going to start with title should be Twitter, and we're going to look at what happens under the hood. Each of these bare words, title, should, and be, are all functions. So we have to work backwards because Perl, it interprets backwards. It starts with be. So the function be expects a code block using this prototype. And what it returns is an expected value. So we put it in an array reference, and I'll explain why in a minute. But because it expects a code block, we have to invoke it. And when we fire off this code block, then we get our expected results. The next thing that Perl reads is should, or invokes anyway, is should. And so we get our arguments, which we expect to be a hash ref. And should is an equality test, and it's a positive one. So we're going to store in an operator, we're going to store EQ for meaning it should be equal to. You saw an example where there was shouldn't, and that would be not equal to. That's a negative type of equality test. Yes?
Is equality more of a property of B? Like, do you have should match, etc.?
Should be and should match and shouldn't be and shouldn't match are all those are phrases that work together. Should be kind of works together in this particular case, but and I couldn't have put it in B because of the way that the calling happens. And it's a little bit verbose. I didn't have to put the word should in here. However, I found it worked better to put it in should because I also have a shouldn't.
Title be something that makes sense.
What's that?
Title be Twitter.
Oh, title be Twitter. Yeah, I don't speak like that, but I'm sure somebody does. So getting to title. So we have a function title, and it expects arguments, which is a hash reference again. And what we're going to do is we're going to set up the input argument with, we're going to call Selenium in this case. So we have a current session because we have stacks that we're working with. We always have a current session. And we're going to call the Selenium objects get title. And that'll return the title of the current page as it's loaded into the web browser. And then we call a state function. And this state function is used for all equality tests. But, and I'll explain that in a moment too. What we do is we pass it in all of the arguments. So we have title should be Twitter. And we're going to break this down in the way that Perl sees it. So B is a function, and it expects a subroutine. And that subroutine returns the string Twitter. Should is a function, and it takes the results of B. And title is a function, which takes the results of should. So another way that we could have invoked title is to just pass it an object reference, a hash reference, with an operator and an expected value. And if you recall, title calls state, which is our equality tester. And so in reality, if we really wanted to, if we didn't want to use this language at all, we could just call state with this hash reference, which is doing all of the work that we did before. So I'm going to show you a simplified state. So state gets arguments as a hash reference. And so we have the value that we got, the value we expected, what kind of operation we want to do. And then we use data compare to compare the got and expected data structures. And that allows us to have arbitrarily deep and complicated data structures as well. So we can compare lists of things and numbers and strings, and it all works out. Now, this test here, if we wanted a negative test, a shouldn't be, then we just reverse the value of compare and return it. Now, in my version, if the comparison didn't work out the way we expected it to, then it raises an exception, and then we deal with that exception. And that exception is cause for the test to fail. That is, the workflow that we're trying to test with Selenium, it didn't work, and we didn't get expected behavior. So we would make a failing test. So we could invoke state this way, But we can also invoke it directly if we wanted to. State of session Selenium get title should be Twitter. But because we're working from the Selenium vocabulary and we've turned it into a sort of natural language, we can just use the shorthand. Title should be Twitter. So incidentally, Yuval, if you said title be Twitter, how would you say that it shouldn't be Twitter without the shouldn't? Title be not Twitter. Yeah. Oh, yeah. All right. Okay. Let's actually look at the shouldn't be case. So you can test the value of a particular field, and so you can say that it shouldn't be something or that it should be something. But here is the shouldn't function. There's a trick, and it's little known, and I'm not sure if that's on purpose or not. But but in any case, you can have this package called shouldn't, and a subroutine inside of it called t. And this does the same thing as the should function. And basically, you can see that we call it with an apostrophe, and apostrophe is sort of a synonym for double colon. You can use it, in any place. If you wanted to, I don't know. If you wanted to call class accessors, you could call it with an apostrophe instead of double colons, and Perl won't complain. But your fellow programmers might complain. And your text editor will certainly complain, because syntax highlighting gets destroyed. Vim understands this? I need to upgrade my Vim. Awesome. Okay, so also we have of, which we hadn't seen before. Of accepts a code block on purpose, as a required argument, and then a list of things optionally. And so here we get our locator and we get our arguments. The locator is the first argument, the code block, and down here for input we invoke it and we put it in a reference again. And then we just stuff that back into args and pass args back up the chain. And so what we're kind of doing here is chaining things together, which at the end, produces a meaningful result. Value is very similar to title. Title and value in this particular language are dynamically generated, but I'm showing you sort of a static version of it, where inside of input we just put the session Selenium get value, and yes, I am actually overwriting input. In my real implementation, it isn't quite this disgusting looking, but that's basically it. And then we call state with the arguments again, and that'll do our equality test. So we can call value of user input shouldn't be no input. And just to break this down again, there's the B function, which accepts a subroutine, which again returns a string. Now, shouldn't is another function, which we call just like that. And just to be clear, this would be the proper way of calling it with the double colons, but you can use the apostrophes, and nobody will complain. Well, again, no, Perl won't complain. Of, we mentioned, takes multiple arguments. So the first one is a code block, and then it takes the value of shouldn't as its second argument. And finally, value is a function which takes the results of. And so we're just making this chain, and the chain passes arguments, and it modifies the understanding of what this particular sentence is supposed to mean. All right, another topic. So stacks in context. I've mentioned this a couple of times that we have session stacks and argument stacks. And we know in Perl, whenever we're writing normal Perl code, that scope can help. That having a lexical scope is a good thing. You should try and use small lexical scopes. So what I tried to do with this language was create lexical scopes. Here's an example of why, and it's kind of contrived, but you have a session, and that session opens up Google and types yapcasia into the query field. And it's supposed to actually click submit, and it didn't do that in this case because my slides didn't have enough room. But presuming that it did, if we got the count of all of the results for yapcasia, then what we can do is open up a second fresh web browser as a new user. And we can open up Google and type in yapc and get the count from there. And then, if we wanted the percentage of all hits that are yapcasia versus yapc, then we can do this test. But a more pragmatic example of why you would want to use this is because you have multiple users interacting with web applications. If you write web applications, then you'll find that if one user can manipulate the state of your application, then another user might feel the side effects. And in this particular case, we can actually create two sessions that are working against one another. One user starts an operation, the other one goes into the web application and changes the state. And then the first user, you can test to make sure that everything worked out the way that we might expect, that we aren't hurting users. So the way that I get away with this is by creating a stack of sessions. And I'll show you my little stack class. It's very bare bones. Might even be wrong, but it works out okay. So this is my package, www.selenium DSL stack. And I have an accumulator, which is sort of a unique identifier for this stack. And I just keep all of my stacks around. Now, one of the design decisions that I made was that if I had multiple kinds of objects that needed a stack, then I would just inherit from this, and that this thing would keep all of the stacks in its own package. I don't really like it, but that's the way I did it at the time. So the stack method just returns all the stacks, or initializes the stack. And we can accumulate and return that accumulator, and this will give us unique identifiers. So then we push onto the stack. Push will create a new kind of context and set that context as the current one. We can pop it back off again, and we can get the current one as we understand it, which will be the last one that was entered into the stack. So our session object, which had ID and things like that, it uses stack as a base class, and then it creates a new method which sets our ID and returns an object. So in this case, what I have are simple stacks. I use this for arguments as well, and I think the benefit is just that I can create lexical scopes and I can nest them together. And I'm going to show you, I think, a little bit of the code. And I'm actually going to try and run the test suite for the piece of work that I've done. I'm not sure if the network will behave for me, but we're going to find out. All right. So I just want you guys to see what happens when I run this. Ah, nothing. Yes. Ah, right. Okay. I know what that does. All right. So I have to start the Selenium server. So that's 10 minutes.
It was 5 minutes. I missed it. In the morning.
Thanks. Okay, so this is creating a new Firefox profile for Selenium. It generates brand new, fresh profiles for every session. And hopefully it will load on that window. Where is it? Ah, it's not. It's loading on mine. Okay, so in any case, it runs. And you guys can't see it. Oh. I I think I can fix that, actually. It's all right, I've got the time. Oh, mirror displays. Okay. There we go. Okay. Yeah, so I'm getting some timeout errors just because of the network, but you can see it operating here. Well, it's trying to operate, that is. So let me show you some stuff. So in this case, this is sort of a rough code, but one of the things that I do is I sort of list all the Selenium commands, and I parse them out and turn them into more Englishy things. And I have a series of DSL commands. Can you guys read that? Is that okay? There we go. I have a series of DSL commands which are fairly standard, and those get exported to whatever is running this code. Here's B, as mentioned, should, of. So I have matching and at, which basically do the same thing as of. So whenever you say text matching, some value should exist. And speaking of exist is a Boolean test. So I just state that I want a Boolean test there. Here is compare, but what I wanted to show you is you can get kind of gross with what you have to do to Perl sometimes, but you can see here that this is how I'm creating equality commands. So if there's a Selenium function like getValue, then I parse it out and I turn it into a value command, and I export that to main. And then inside of it, I basically get the results of calling Selenium, and I check whether or not we're doing a Boolean test. Sometimes we're not doing any test at all. So if you say, a value of input field, if you're not doing any test at all, I'll just return the result, and then you can use that in assignment. So you can assign the value of a text field. But there's a bunch of crazy code in here. So one last thing. Let's see if that works. Cool. So I wanted to not just make it English, and this doesn't work quite well. Marty explained that I have my word order all messed up, but I don't do Japanese. But I believe this says parento and then 6, and then 2 times 3 equals this many. So if that's right, then if you ran this command, then that's what would happen. And so you can actually run Japanese. You can write Japanese functions, and that's what we've done here. It's really simple. So I have a package called JACounters, and I have to use UTF-8 and encode, and I just use base exporter. So what I do is I have my numbers, and if I'm right, that's 1 through 10. And I have another subroutine, parento, and I export them both. So whenever I create them, I go into Perl's symbol table and just create them correctly. So for 1 through all the numbers, create a new function with the Japanese name, and it will take its first argument and multiply it, or it'll take the string that we had and make a string that's 6 times as big by duplicating it. And then here's parento, which just prints an encoded version of whatever you passed in. So it's just sort of like alias to Perl's print. And then all modules have to return 1. So, or a true value. So then if you just use JACounters, then you can use this Japanese code. And I believe that's it. So questions, I guess. Oh yeah. So you can write in a domain language that's a computer programming language, or a written language or both. It doesn't matter. And Pro gives you that flexibility. That's the thing I wanted to state. So.
質問とかある方いますか Any questions? どうぞ。
Who actually write these Selenium tests using the DSL? Is it programmers or is it the programmer as well?
Okay. So do you want to?
質問はこのセミニアムのDSL を使って誰がどういう人がテストを書いてるのかってことです。
Right. So who writes these tests, programmers or not? Right now, what we've done is there's a Selenium IDE for JavaScript or for Firefox that lets you write Selenium tests, and it will produce them in multiple languages. And I've written a specific one that outputs this grammar. So what we're doing now is that programmers and QA quality assurance people are manually clicking through the application and writing this test suite. And they're doing it with Firefox and then just saving that as program files, which are executable right off the bat. So I've written an interpreter which I didn't have time to show, but you can actually interpret them directly. They're then being tweaked by programmers right now, but the goal is once I get it fleshed out a little more that we'll push that into the QA department and they'll be doing more of that. And then we print them out sometimes and give them to product managers, and they can sort of read through it and make sure it seems like it's the right thing for the application to be doing.
セリニウム用、Firefox 用セリニウムのプラグインがあるので、それを使って、プログラマーと QA の人たちが、実際にクリックとかをしていくと、今の、DSL を書き出すようにしてあると。で、それを今度は使って逆に実行可能なファイルにして、それを使って実際のテストを行っているということです。Any other questions?
No, I didn't. I'm not sure I actually know what you mean, but that may be because I'm not smart. I'm not smart enough.
Okay. Anything else? Okay. No, done.
Okay, thank you.